Hi friends, this is Naresh. Today I am going to explain about engineering drawing, and the topic is importance of engineering skills in our daily life. It is not always possible or convenient to draw drawings of an object to its actual size. For instance, drawings of very big objects cannot be prepared in full size because they would be too big to accommodate on a drawing sheet. Okay, drawings of very small objects like precision instruments also can't be prepared in full size because they would be too small to draw and to read. Okay, these are the preferred drawing sheet sizes. Now these are the first choice. Now these are the second choice. Here the drawing sheet sizes are designated by A0, A1, A2, A3, A4. The size of A0 drawing sheet is 841 mm by 1189 mm, whereas A1, the size of A1 drawing sheet is 594 by 841. Okay, and the size of A2 is 420 by 594. The size of A3 drawing sheet is 297 by 420 mm. The size of A4 sheet or A4 drawing sheet is 210 by 297 mm. Okay, now here the maximum length of a drawing sheet is 1189. Okay, above 1189 we can't draw actual size. So for very big objects you have to reduce that size. Okay, these are the standard drawing sheet sizes. Okay, now these formulas are very useful for calculating the scales. Scales are represented by RF value, that is a representative factor. The representative factor means it is the ratio of size of drawing or dimension of drawing to the actual size of object. Okay, so representative fraction is the ratio of size of drawing on a drawing sheet to the size of original object. Okay, it can also written as length of drawing to the actual length, whereas for areas, for plots, the RF value, the formula for RF value is equal to square root of area of drawing divided by actual area. So that means the actual area means original size of the land, and area of drawing means size of drawing represented on a drawing sheet. Okay, for in case of volumes, that means solid objects or three-dimensional objects, the formula for RF equal to square root of cube root of volume as per drawing divided by actual volume. Okay, actual volume means original size, and volume as per drawing means size of object on drawing sheet. Okay, so RF equal to, therefore representative fraction is equal to size of object on drawing sheet divided by original size of object. Okay, Now for length of scale equal to RF into maximum length to be measured. Okay, these formulas are used in problems. Now scales are broadly classified into full size scales, reduced scales and enlarged scales. Okay, what is full size scale? If we show the actual length of an object on a drawing sheet, then the scale used is called full size scale. Okay, then RF value equal to 1:1. Okay, RF value means size of object on drawing sheet. Okay, size of object on drawing sheet divided by original size of an object. Okay, here in case of full size scale, the size of original object is equal to the size of drawing. Okay, dimension of drawing is equal to original size of object. Okay, then representative fraction RF equal to 1:1. Okay, for example, if we want to draw this figure on drawing sheet, here the maximum length of the drawing is 55 and 50, so it is very small dimension, so you can easily draw on drawing sheet. So you have to take original dimensions as drawing dimensions. So on drawing sheet you have to represent the scale value, that is a scale equal to 1:1. Okay, 1:1 means the size of drawing equal to size of original object. Okay, this symbol is used for type of projection, that is first angle projection or third angle projection. It is a title bar and name of the institution or name of the company. Okay, this is a title box for drawing sheets. On drawing sheets you have to represent the value of scale. Okay, similarly here if you want to draw this machine component on drawing sheet, here the maximum dimension is 85, 150 and that. Here look here the maximum dimension is 150 mm. 150 plus nearly 30 or 40, total 200, maybe 250 or 200 mm. So it can also you can draw you can easily draw on drawing sheet. Okay, so you can draw the original dimensions on drawing. So the size of drawing sheet, the size of object on drawing sheet equal to original size. Therefore here the scale is also 1:1. Okay, it is full size scale. Okay, now coming to the next type, that is a reduced scale. If we reduce the actual length of an object so as to accommodate that object on drawing sheet, then the scale used is called reducing scale. Okay, such scales are used for the preparation of drawings of large machine parts, buildings, bridges, survey maps, architectural drawings, etc. Here the representative fraction is always less than 1. Okay, that means here the size of original object is very large. Okay, the size of object on drawing sheet is small. Okay, so for example these are the examples of RF values: 1:2 or 3:100 or 1:5000. These are the examples. Here the value, the size of drawing is very small as compared to size of original object. Okay, it is not it is not always possible or convenient to draw drawings of an object to its actual size. Okay, drawings of very big objects cannot be prepared in full size. Okay, here the the maximum length of this component is 1800 mm, so it cannot draw on drawing sheet. Okay, because the maximum size of drawing sheet is 1200 mm, 1300 mm. Okay, but the size of this machine component is 1800 mm, so you cannot draw on drawing sheet directly. So first of all you have to take some suitable scale, that is a reduced scale. Okay, and another example is, this is the original size of architectural building for at the time of construction. Before construction you have to prepare some drawing sheets for building plannings. This is the building planning. Here this is original size of an object, but it is the drawing size of an object. So in this case the size of drawing is very small as compared to size of actual size. So here RF value equal to size of drawing divided by size of original object. Okay, the drawings of very big objects like buildings, machine components, or machine components cannot be prepared in full size because they would be too big to accommodate on drawing sheet. Okay, it is also similar. This is the building plan used in civil constructions. Now it is a this is a lathe tailstock. The dimensions here also I am taking a scale as 1:5, that means reduced scale. The value of drawing object is small as compared to size of original object. Okay, this is also a reduced scale. Now coming to the enlarged scales, drawings of very small objects like precision instruments, namely watches, electronic devices, circuit boards, uh, like this, also cannot be prepared in full size because they would be too small to draw and to read. Okay, here the value of a representative fraction is always greater than 1. Okay, therefore the value of RF is always greater than 1 because the size of original object is very small, but the size of drawing is very high compared to the original object. Okay, here the value of numerator is very big as compared to denominator, so the value of RF is always greater than 1. In case of full size scale, the RF value equal to 1:1, that means RF equal to 1. In case of reduced scale, the RF value is always less than 1. In case of enlarged scale, the RF value is always greater than 1. Okay, here these are the examples. Drawings of very small objects like precision instruments, and these gears, small gears, electronic circuits cannot be prepared in full size because they would be too small too small to draw and to read. Okay, therefore a convenient scale is always chosen to prepare the drawings of big as well as small objects in proportionally smaller or larger sizes. So the scales are used to prepare a drawing at a full size, reduced size or enlarged size. Okay, thank you.